we have in section 3 to learn, triangular form. This system of three equations is in triangular form because it looks like a triangle. You get the idea. It looks like a triangle if we drew something right around it. Triangular form, we have three variables, three equations. The first equation is all three variables. The second equation only has the second two. And the last equation only has the third one. And that means it's already solved for one of the variables when it's in triangular form. And so when they say solve a system, and if it's already in triangular form, it's pretty simple. I already know what z is, and we can just start back substituting and figure out what the other values are. Y minus 2 times 3 must equal negative 7. Y minus 6 is negative 7. Y must equal negative 1. We now know what y is, and we can come all the way to the top. X minus 2 times y plus our z, what was it, 3, must equal a 7. So what do we have? 2 plus 3? X plus 5 is 7. What's x? X is 2. Now this is an ordered triple. X, comma, y, comma, z. X, comma, y, comma, z. So our solution of this one, 2, negative 1, 3. 2, comma, negative 1, comma, 3. So triangular form is a very convenient form. One thing is solved for, back substitute, and we get all the rest of it. So if I was going to guess, we might want to get it into triangular form. Gaussian elimination. Now in reality, we are going to be using the elimination idea. Gaussian elimination is the title of it. And there are really three things that we can do in a system of equations, three rules we can follow in order to get it into triangular form is what we're going to try to do, and then we're going to solve the system. We can interchange any two equations. There's no order to the system of equations. We can swap 1 with 3 or whatever it happens to be. We can multiply one of the equations by any non-zero real number. It says or divide. So just like we learned in math earlier, I can multiply both sides of an equation by a number. It's still true. And this thing is really the elimination step. Add a multiple of one equation to any other equation in the system and replace it with the answer. That's eliminating, where I've multiplied it by a number, then I add them together and I get a new answer. That's the elimination stuff. So we are going to change this into triangular form. And triangular form again, let's back up. We want to have the first row, x, y, z, second just y and z, and the third just z. And we want to practice getting a 1x in this first spot. That's going to lead to the next thing we get to. So as I look at this system, well, 1x in that very first row, that one's perfect. Let's just leave as is. Now in the second row, I want to eliminate this x term, that 3. Well, if I look above, I could multiply this one by a negative 3, and it would eliminate it. So in my next step, here's a system. In my next step, I'm going to have 3. I'm going to keep that first equation. X minus 2y plus z equals 7, just like it is. But mentally, we are going to multiply it by negative 3, add it to the second row, and write our answer there in the second row. So negative 3x plus 3x, 0. 6y minus 5y, 1y, y. Negative 3z plus z, negative 2z. Negative 21 plus 14, negative 7. And there we have our second row in the form that we want. Now, I also want to eliminate in this third row that x and the y, but we're not going to do two at once. We're just going to do one thing at a time. So if I want to eliminate that x, well, I can use my first equation again. I can multiply it by a negative 2, add it to that third one, and it will eliminate the x's. So we will mentally do that. Negative 2x plus 2x, that x is gone. 4y minus 2y, 2y. Negative 2z minus z, negative 3z. Negative 14 plus 3, negative 11. Now we have row 1 how we like it, row 2 how we like it. We just need to work on row 3 now, eliminating the y. And we will eliminate this y by looking right above it. We're going to use this y in order to eliminate. We're going to multiply everything here by a negative 2. So in my next set, the first 2 equations are just how I want them. They're already in the triangular form. Y minus 2z equals negative 7. Now we'll do our math here. Negative 2y plus 2y, y's are gone. 4z minus 3z, z, equals 14 minus 11, 3. There's triangular form. And once I have triangular form, I have one answer. Let's come up here. Y, let's mentally do it. Put a 3 there, that's minus 6, right? Is this the same equation? Y equals negative 1. This is the one we just did, I think. And then I'm going to take the top one, x, let's see, minus 2 times y. What's y? Negative 1, negative 2, negative 1 is plus 2. Plus z, plus 3 equals 7. That's 5, so subtract the 5, and x is 2. So our ordered triple, 2, negative 1, 3. Otherwise, they had us do 2 of the same ones twice. But anyway, there it is, triangular form. So what does it look like when we have a new solution system? Well, let's try it out. Here are our first 3. This one's already good, 1x. That looks beautiful. I want to eliminate this x. What can I do to do that?
Just add first 2.
Just add the first 2. It's already set up. So I'm going to copy the first one. X minus 3y plus z equals 4. And then mentally we will do that math. Add them together. X's are gone. Negative y. Z minus 5z, negative 4z, 4 and 3 make 7. I want to eliminate the x down here as well. So I'm going to go back to the top again. And what can I do in order to eliminate that 5x? Negative 5. We multiplied that one by negative 5. So we'll do it mentally. Negative 5x plus 5x, x is gone. 15y minus 13y, 2y. Negative 5z plus 13 plus 8z. Negative 20 plus 8, negative 12. Okay, now I'm going to work on the y's, because we have the, well, we don't quite have the second one. I want to do something else. I don't want that negative there. Multiply by negative 1. You know, even as I say it, that's okay. Let's leave it there. Let's get rid of the y right down here. So what do I need to do in order to get rid of the y? We just look above.
Times 2.
Multiply by 2. All right. First equation is done. X minus 3y plus z equals 4. Second one is good. Negative y minus 4z equals 7. Let's work on the third one. Negative 2y plus 2y. Y's are gone. Negative 8z plus 8z. 0. That's gone. In other words, I have 0 on this side. 2 times 10 is 14. 14 minus 12 is... And there it is. That's not true. We have no solution to this system. So we've seen stuff like that before, so it's not really so different. It's like, oh, I recognize that. That one's not going to work. So let's integrate our system of equations with matrices, since we have been learning matrices. We have what is called an augmented matrix, which comes from a system of equations. And you notice there are just numbers in this matrix, and those numbers are simply the coefficients and the constant that it equals. So that top row, 1, negative 2, 1, 7, it's just the coefficients and the number. So that's called an augmented matrix when I write a whole system just in one big matrix. Now if I just do the coefficients, we call that the coefficient matrix of the system. So pretty easy. Then we are going to, on the matrices, perform what are called, we want to perform elementary row operations. There we go. We want to perform elementary row operations on it to turn it into a row echelon form matrix. Now they explain it right down here. A row echelon form matrix looks like this. 1, and then 1x, and then it has the y, and then it has the z, and then it has some number. In other words, the x, y, and z are values. Then there is a 0 here, and actually let me erase, sorry. Let me just do the numbers. I have 1x. I have, oh, yeah, that's a number. I'm going to put it back. That's some number, and that's some number, and then this equals a constant out there. Then I have 0 x's here, and 1 y, and then I have a z number, and I have a constant. I have 0 x's, 0 y's, 1 z, and then some constant down here. This is just like what we had earlier. 1z equals that constant, whatever it is. This is triangular form in a matrix. Notice we have an echelon of 1s. An echelon is, if you have planes in echelon formation, they're just in a diagonal, one right after the other in a diagonal. That's what echelon is. And then the zeros out here. So you notice, rows consisting entirely of zeros, if there are any, are going to go on the bottom. Now this one, we don't have all zeros, we have a 1 down there. But if there are any, they'd be on the bottom. The first entry in any row is 1. There you go. First entry is 1 as long as it's not a 0. It's a 1. The column subscript of the leading 1 entries increases as the row subscript increases. That's just the way of saying, as the row goes up 1, the column needs to go up 1. It moves it over. That's just a fancy way of saying this is what it looks like with those diagonal 1s and the zeros on the left. Now the elementary row operations that we do are exactly the same things we just talked about getting triangular form. We can interchange 2 rows in a matrix. We can multiply all the elements in a row by a non-zero number, and then the elimination part, add a multiple of one row to another row. So really, when we talk about using a system, solving a system by putting it into a matrix in row echelon form, it's just dropping the variables and only dealing with the numbers. And then I'm going to show you a notation that we write. So I'm going to write the augmented matrix. 1, -1, 2, -3. 2, 1, -1, 0. Now we need to make sure it's x, y, z, x, y, z, x, y, z, which it is. -1, 2, -3, 7. I have right here my 1 just like I want. So row 1 is just how I like it. We're going to leave it. Now I want to move down and eliminate this, and then eliminate this, just like we were doing earlier. So I am going to do 2 steps to get the next thing. If I want to eliminate this 2, what will I do with that 1 above it in order to eliminate that 2? Yeah. I'm going to go -2 times row 1 and add it to row 2. That's the notation of the elementary row operation that we're going to do. Now let's just do that one. Remember, the first row is just how I want it. 1, -1, 2, -3. 1, -1, 2, -3. Now I have to be careful and try to keep everything lined up so we don't get confused. Now we're going to do this elementary row operation. -2 times row 1, add it to row 2. -2 plus 2, 0. There goes my answer. -2 times that is a 2 plus 1, 3. -2 times 2, -4 plus a -1, -5. -2 times that -3 is 6 plus 0, 6. Now I'm going to do this third row. We're going to get rid of that -1. What will we need to do with the first row to go down and get rid of it? Just add it. Row 1 plus row 3. That's all we're going to do. So 1 plus -1, 0. -1 plus 2, 1. 2 minus 3, -1. -3 and 7, 4. Now notice, the first row is all done. The second row, well, I have my 0, but I need a 1 where that 3 is at. Here's where we will do, let me back up. Here's where we will do number 2. Multiply all elements of a row by a non-zero number. I want to convert it to be a 1. Anytime you want to be a 1, I'm going to move this over so I have room to write what I am doing. Anytime I want to have a 1, I'm just going to multiply 1/3 times row 2, and that will change it to a 1. Now you can say, oh, I'm dividing by 3. You're right. We write the multiplication. So our next system here, our next matrix, I'm going to copy the top row. We're done with that row. 1, -1, 2, -3. It's just like we want. I'm not going to do anything with the third row on this operation. I'm just turning that into a 1. So I'm going to copy the third row, 0, 1, negative 1, 4. Now I'm going to do that row operation, multiply it by 1/3. 0, 1, negative 5/3, 2. I have second row just like I wanted. It's a 0, then a 1. Now under this 1 we just made, I'm going to use that to get rid of this 1. How can I do that? Negative 1 times row 2 added to row 3. So let's see what we get when we do that. Now again, the first two are done. Just copy them. And I like to copy the ones I'm done with first so that I don't forget and eliminate some of my mistakes if I just first. Well, let's copy the ones that I already know what they are. And 2. Now I'll do my math, my row operation. So negative 1 times row 2 and add it. Well, 0 plus 0 is 0. Negative 1 plus, 0 plus 0 is 0. Negative 1 plus 1, 0. Negative 1 times negative 5/3 is 5/3. 5/3 minus 3/3. What's 5 minus 3? 2/3. That makes it a positive minus 2/3. 2/3. Let's see, negative 2 plus 4?
Negative 6. Negative 2.
Positive 2.
Positive.
Negative 1 times that 2, so negative 2 plus 4, 2. So we have to be careful with our mental math here. All right, now I want to get a 1 in that location for row echelon form. What can I multiply it by to get a 1? Just multiply it by 3 over 2, right? It'll change it to a 1. And what I am wanting is a 1 in that location. First row, 1, negative 1, 2, negative 3. 0, 1, negative 5/3, 2. Last row times 3 over 2, we'll multiply by 0, you still get 0. 3 over 2 times 2 over 3 is 1. 3 over 2 times 2? 3. There is row echelon form that we just made. Now their question was, solve the system by finding this row echelon form. Well, this represents the system of equations where, I'm going to start with the last row, x, y, z, 1z equals 3. That's what that bottom line is. This again is triangular form in a matrix. And then coming back up, 0x's, 1y, it's y minus 5/3 z equals 2, and then it's x minus y plus 2z equals negative 3. This is the system that that matrix stands for. And we have our first system, so we'll just substitute it back in. Y minus 5/3 times 3 equals 2. Well, 5/3 times 3 is just y minus 5, so add my 5, and what is y? 7. And now we can come back up to the top. X minus our y, 7 plus 2 times our z. What was a z? A 3 is supposed to equal a negative 3, so that's 6. Negative 7 plus 6, negative 1. Add my 1. We have our answer. X is negative 2, y is 7, z is 3. And we used a matrix, put it into row echelon form to help us do it. That's the idea. We get to practice with row echelon form, and we'll see what happens here. Well, let's start with our first matrix. 1, 1, 1, 3. There's our first row. 2, 1, 4, 8, 1, 2, negative 1, 1. Row 1, just like we want it. So let's eliminate here and here. How will we get rid of that first 2? Negative 2 times row 1 and add it to row 2, right? How will we get rid of that bottom 1? Negative 1 times row 1 and add it to row 3. So we are going to do those 2 operations. So my first line is good. 1, 1, 1, 3. 1, 1, 1, 3. What are we doing? Negative 2? Negative 2 plus 2, 0. Negative 2 plus 1, negative 1. Negative 2 plus 4, 2. Negative 6 and 8, 2. Negative of row 1 added to row 3. Negative 1 plus 1, 0. Negative 1 plus 2, 1. Negative 1 minus 1, negative 2. Negative 3 plus 1, negative 2. Now I notice on this one that this third row has that 1 that I really would like up in the second row. Well, we'll just flip them. We are going to take row 2 and interchange it with row 3. So, my next one. Let's see, first row, all done. 1, 1, 1, 3. And then flip the rows, interchange them. 0, 1, negative 2, negative 2, and then 0, negative 1, 2, 2. So now my first two rows exactly how I want them. Now I come underneath that one to get this one. How do I do it? Just add them together. Row 2 plus row 3 is all I need to do. So let's see again here. 1, 1, 1, 3. 1, 1, 1, 3. So this method takes a little time. Just be careful on the little steps. You hate to mess up like on the second line, because then you know what it means. Everything below that is wrong. So just be careful. Second row is good. 0, 1, negative 2, negative 2. 0, 1, negative 2, negative 2. Now what are we doing? Just adding row 2 and 3 together, aren't we? 0 and 0 is 0. 1, negative 1 is 0. Negative 2, 2 is 0. Negative 2, 2 is 0. Now we need to, that's right. Remember there's like an equal sign here. 0 on the left equals 0. That is true. That is one of our infinitely many solutions. So here's how we're going to write our answers on these. We are going to take our last z and just say z is z. Some books say just call it a constant, c or something like that. Z is z. And then we'll work our way backwards. I'm going to take this row. So that's 1y minus 2 times the z equals a negative 2. And we'll solve for our y. Add 2z minus 2. So our y is 2z minus 2. And then we can back up and get our x value, our top row up there. So what do we have? X plus 1y, and there's y, plus 2z minus 2, plus a z equals 3. And we want to solve for the x. Let me see. 2z and z. X plus 3z. I'm going to add the 2. That makes 5. Subtract 3z. Negative 3z plus 5. There's x. Negative 3z plus 5. There is our solution to infinitely many solutions. We can pick any z that we want and generate the x and the y that go with it. And it will be one of the solutions that go on it. Now this one is also an infinitely many. How many variables are in this system? 4 variables. How many equations do you see? 3 equations. Now right away, you know we can't get one answer out of this. This is called a non-square system. A square system, we have 3 variables, 3 equations. We can potentially solve those. So we have x, y, z, w. Well, let's do this matrix. 1x, 2y, negative 3z, 0w, negative 1. 2, 3, negative 4, 1, negative 1. 3, 5, negative 7, 1, negative 2. Now I still want to try to do row echelon form as far as I potentially can. And this row 1 is good. We have a 1 right there. I'll never leave myself enough room, do I? That'll fix it. So how am I going to eliminate these 2? How do we do that one? There you go. And to get rid of the 3, negative 3 times row 1 and add it to row 3. So there's the 2 elementary row operations we are going to do on this. First row, 1, 2, negative 3. 1, 2, negative 3, 0, negative 1. All right, what are we doing? Negative 2 times the first. Negative 2 plus 2, 0. Negative 4 plus 3, negative 1. 6 minus 4, Well, 0 plus 1 is 1. 2 minus 1, 1. Now negative 3 times the first row. Negative 3 plus 3, 0. Negative 6 plus 5, 9 minus 7. Well, 0 plus 1, 1. Then what do we have? 3 minus 2, 1. Hey, we do notice those last two are the same equation. But let's keep going with this row echelon form. Means they already told us we're going to have infinitely many. I'm going to do negative 1 times row 2. I need to have a positive 1 right there. 1, 2, negative 3, 0, negative 1. This is good for patience. 0, 1, negative 2, negative 1, negative 1. I'm going to leave that last one 0, negative 1, 2, 1, 1. Now we're going to eliminate this by going, just adding row 2 plus row 3, right? Okay, row 1 again. 1, 2, negative 3, 0, negative 1. And 0, 1, negative 2, negative 1, negative 1. Second row, just how it is. Now we're going to add it together. 0 and 0 make 0. 1, negative 1 make 0. Make 0. Make 0. Make 0. So there's a case where once again 0 equals 0. True, infinitely many solutions. But we don't know W, the last one. Whoops, W, the last one. We don't know Z, and now we can start with this row and get Y in terms of Z and W. So that second row, 1Y minus 2Z minus a W equals a negative 1, so Y must equal 2Z plus W minus 1. 2Z plus W minus 1. And then row 1. X, what do we have? 2Y. So plus 2 times 2Z plus W minus 1. That's our Y. Plus R, Z plus R. Oh, wait a minute.
Minus 3Z.
Minus 3Z. Minus 3Z. 0W, so that's nice. Equals negative 1. Okay, x plus 4z plus 2z minus 2 minus 3z equals negative 1. Let's just figure out. Uh-oh. W. See, you don't want to make one of those little mistakes. W. All right, I have 4z minus 3z, so I have 1z. Subtracting it, negative z.
Minus
2w, subtract it. Minus 2w. We have a negative 2, so add that negative 2 to that 1, plus 1. There's our x. X is negative z minus 2w plus 1. There's our answer for that infinitely many solution 1. You'd have to pick two values. Pick a w, pick a z, and then you could generate the others. Inverse matrices. Okay, we got through solving systems by what's called row echelon form of a matrix. Now we are going to learn about inverse matrices and solving. Now let's go back to some numbers. If I have 2/3 x equals 8, and you are supposed to solve for x, what would you do?
multiply by 3.
You would multiply by 3 over 2, right? Now, I'm going to move that 8 over just a little. I'm going to have to rewrite that to move that 8 over just a little. In numbers, it doesn't matter whether I multiply by 3 over 2 in front of the 8 or after the 8. But we learned in matrices the commutative property does not hold true. So if I multiply on the left, we have to stay on the left. So we know that would be 1x equals 12, or x equals 12. Now I wrote that one for a minute. That's called the multiplicative identity. When I multiply inverses together, I get the identity. We are going to be doing this with matrices. we are going to write this system of equations as a matrix equation. Coefficient matrix, 3, -2, -1, 1. Variable matrix, xy. Now if I multiply these together, row times column, it would be 3x minus 2y, just like we started, equals the constants out here, 0 and 5. We've rearranged that linear system into a matrix system. Now the idea is the same as over here. If I multiply by the inverse, let's say that's matrix A. If I multiply by the inverse of A, then that goes to the identity 1. And I just have xy, which means I need to multiply by the inverse right over here. So in other words, this is going to be our answer right there. So in order to get our answer, I have to get the inverse. What the inverse is. We learned how to get the inverse the other day. 1 divided by the determinant of this. 3 times 1 is 3, minus -1 times -2 is 2. 3 minus 2. Times, and we have to rearrange this matrix. 3 and 1 switch, remember, and change the signs on the other diagonal. Now, it happened to be nice. 3 minus 2 is 1. 1 over 1 is just 1. So 1 times that matrix, this is the identity in this case. 1, 2, 1, 3. There's our identity. So that is what we want to multiply by the constants, and we have our answer. So I will know that xy, this thing right here, xy, should equal this inverse 1, 2, 1, 3 times the constants 0, 5. And I will know what xy is. This right here is the solution. So xy must equal, well, let's look real quick. What's the order of this first matrix?
2 times 2.
It's a 2 by 2. What's the second one?
2 times 1.
A 2 by 1. So we're going to get a 2. We can do it, and we're going to get a 2 by 1 answer. 2 row, 1 column answer, which is what we want. 2 rows and just 1 column here in that row. So first number. 1 times 0 is 0. 2 times 5 is 10. Then the second row, 1 times 0 is 0. 3 times 5 is 15. Well, in other words, we get 10, 15, right? That's the x and y. In other words, x is 10, y is 15. Inverse matrix. Now when we, let me pull this up. This is what we just did. We multiplied the inverse matrix times those constants, which they're calling b right over there, and we get our solution. When we have a 2 by 2, I want you to do it by hand. When we have this little 2 system, we're going to do it by hand. But when we get down to a 3 system, we are going to use the calculators in order to solve this thing. We're going to put our calculators to work. Now notice, they've already written, here's the system. They made the A matrix, that coefficient matrix. There's the XYZ matrix. There's the constants. So we know to get the answer, we want to take the inverse of the A matrix and multiply it by this B matrix. Let's just enter in the A matrix and the B matrix. So start entering. I need to get my calculator up, and I'll start entering. Move it in my record area. Second matrix. We're going to edit that first matrix. It's a 3 by 3, so that all looks good. My first matrix, I quit, go back to my matrix, go back to edit. I'm going to edit the second one. And the second one is matrix B, a 3 by 1. Okay, 20, 40, 30. And now I'm going to quit. So Now I'm going to go back to matrix, second matrix.
1.
Matrix A is the one we want. Matrix B is the one we want. We just want to take matrix A, so I'm going to hit enter in matrix A and hit my inverse button, inverse of matrix A. Go back to the matrix. I don't even have to say times. Choose matrix B, and I should have done the fractions. Let me do it again. Second, clear it all off. Second matrix. We're going to take matrix A, the inverse, matrix B, and I'm going to go to the math and say, write my answer as fractions. There we go. We have the answer, x, y, and z. X is 18, y is 118 thirds, and z is 14. This is where matrices become powerful, is when you have more complicated things, and we use software to do it. We now know a technique where we can use a matrix on any system of equations and we can solve it using that inverse idea right there. So let's do an application, and we'll use our calculators to help us out on this application. If I have any 3 points, as long as they're not collinear, we can fit a conic section to it. Now, there are lots of conic sections. They happen to want us to do a parabola. You can find a parabola that goes through any 3 non-collinear points. You can find a circle that goes through any 3, etc., an ellipse, a hyperbola. But they're doing the parabola. Now, a parabola comes from a quadratic equation, ax squared plus bx plus c. We happen to know 3 different x and y values. So we can write 3 different equations, one for each of those points. The y is like my f of x. That's my y equals. So I can say for that first point, that point -1 comma 5, I know that 5 equals, and I put a -1 in my x's. I'm substituting them in. So -1 squared times a is a. -1 times b is a -b. Plus c, because there's no x to go with that one. And then we're going to use our next point, the point 2, -1. Well, -1 is our answer when I put a 2 in the x spot. 2 squared is 4, 4a. Plus 2b, plus c. And then the last one, 3, 13. We know 13 is the answer when I put a 3 in the x spot. 3 squared, 9. 9a plus 3b plus c. That is a system of 3 equations and 3 unknowns. So we're going to change it into a matrix. And we will call our matrix A that coefficient matrix. 1, -1, 1. And 4, 2, 1. And 9, 3, 1. And we're going to call our B matrix the constants, the answers. 5, -1, 13. And it's now a race. Who can enter it in their calculator faster and get the right answer? I can't even find my calculator. There it is. See if I can get it where everything can be seen. You're already there. I'm still there. B, there we go. Is that what you got, or did I make a mistake?
This one.
Oh, no. Did I make a mistake?
Only 6.
I think I did. Let me go back and look at my matrices. That is that first matrix. 1, -1, 1. 4, 2, 1. 9, 3, 1. Well, that's okay. goofed up on this one.
5 negative 1.
5, negative 113, that's okay. Matrix A, inverse. I can't figure out what's wrong. Matrix B. What are you getting?
I'm just going to 4 negative 6 5.
4, negative 6 5. 4, negative 6 5. That's what you should be getting. I don't see what I've entered wrong, but you should be getting 4, negative 6 and 5. X equals inverse matrix A times matrix B, which is 4, negative 6, 5. That is what you're supposed to be getting. Negative 5? Negative 5. Now, this, I guess I really shouldn't have put it in an ordered pair. This is A, B, and C. A is 4, B is negative 6, C is negative 5. So we can go back and write the equation, or the function, f of x, or y equals, 4 is A, so ax squared, 4x squared, minus 6x, minus 5. And I happen to have graphed it earlier when I did find the right numbers. And there is the equation, and sure enough, it's a parabola that hits all 3 of those points. So that's just a little application. I missed a number somewhere when I was doing that. All right, that's today's.